Hello, everyone. Welcome to the January 2022 MassTimber webinar, assembled in 20 days. And this is about a new MassTimber affordable housing model being advanced in Canada by Element 5. My name is Sandra Lupien, and I am your moderator today. I'm the director of the program MassTimber at MSU, which is a co-producer of this webinar series. At MassTimber at MSU, we mobilize education, science, outreach, research, and communication to advance mass timber construction and manufacture in Michigan and the surrounding region. MassTimber at MSU is housed at Michigan State University in East Lansing, and it's a collaboration across our Department of Forestry, our School of Planning, Design, and Construction, and the MSU Extension. And we also receive funding and support and partnership from the Michigan Department of Natural Resources and the Michigan Department of Agriculture and Rural Development. Our co-producer for this webinar series is the Michigan Forest Biomaterials Institute, MIFB. And MIFB fosters sustainable forests, communities, and economies through innovative and responsible production, use, and recycling of forest biomaterials. MIFB serves several key functions. They're conveners and educators. They're a volunteer-driven organization, and they're independent and nonprofit. And I know some of my collaborators from MIFB are here on the webinar. And so hello, MIFB folks. It's nice to have you here. And thanks for your partnership on this webinar series. So today for this webinar, just a couple of logistics. This is a Zoom webinar, so when you arrive on the call, your microphone and your audio are muted, and your video is off, and it will stay that way for the duration of the webinar. If you have questions, we will very likely hold for questions until the end of the webinar. I'll be monitoring the Q&A section of the Zoom features, and you can find the Q&A function in your controls, probably at the bottom of your screen, Q&A. So if you have a question, just go ahead and type it in there, and I will respond when I can, or I'll bring that question to our guest and our other panelists in the Q&A session when that time comes. So I am very excited about this webinar today. I have been thinking about mass timber and affordable housing for a number of years, and we're starting to hear more interest in mass timber for affordable housing across the United States. So, you know, across the US, communities face unprecedented shortages of affordable housing. According to the National Low Income Housing Coalition, Michigan alone lacks 200,728 rental units to house low-income residents. And you can see that number circled in red at the center of the screen, which I hope everyone can see clearly. Those seeking to close this gap in affordable housing are, like I said, increasingly raising mass timber as an option because it's of its sustainability, but also because of the ability often to build projects more quickly with mass timber than with other types of structural systems. We're not going to go necessarily into those reasons in this introduction, but our guest will talk a little bit about some of those efficiencies in construction. And that's an appealing reason to consider building affordable housing, which we need to build quickly in order to get people housed, to build quickly. And I think that's a very exciting prospect. So as more discussion about mass timber for affordable housing starts to emerge, people in Michigan are starting to wonder how this might work. People across the country are asking, how do the numbers work? Is it affordable to build affordable housing with mass timber? And what we're finding with emerging models is that perhaps it may be. And our guest today is going to talk about one such model. Here is an example of just one affordable housing project that's in development in Los Angeles on Skid Row, which is, I'm sure, the highest concentration of people experiencing homelessness in a geographic area in the country. This mass timber tower, affordable housing development, 14 stories, 77,000 square feet, using cross-laminated timber and other mass timber materials for the structural system. And this is by Michael Maltzahn Architecture. So just one example that's starting to emerge. But today we're going to focus on what's going on at Element 5. And our guest today is Patrick Chouinard, the co-founder and vice president of market development and corporate communications of the Ontario-based Element 5. And this is the newest cross-laminated timber and glue-laminated timber manufacturer in North America that specializes in the design, fabrication, and assembly of mass timber buildings. Now, Patrick, as you'll discover, is a passionate advocate for construction industry transformation, and he believes that prefabricated mass timber construction is the key to significant gains in construction efficiency and building performances needed to meet significant housing and infrastructure needs in a sustainable way that contributes to a low carbon future. So I'm on board with that, and I think you are all here because you're on board with that. To that end, Patrick and Element 5 have innovated a mass timber affordable housing product that's been attracting a lot of attention. And I'm grateful to you, Patrick, for joining us today to talk about this product. So I invite you to kick off your part of this presentation, and I'll be advancing your slides for you, so you can just go ahead and cue me when you're ready. But now that you're on the mic, can you tell me if my screen looks okay? Because I can't tell from my end. Can you see your slides okay?
Yes, yeah, if you're referring to me, yes, I can.
Yes. Okay, great.
Bit of a time delay, I'm afraid, though. It seems to be taking a while for it to appear on my screen. Okay. So yes, it just finally appeared on my screen. So
we'll adapt.
Okay, thanks. Thank you very much, Sandra. I really appreciate the opportunity to present today, and thank you to all the attendees for taking time to join my presentation. We are Element 5, and we consider ourselves to be world leaders in this new mass timber revolution. And the photograph that you see here is of our brand new mass timber manufacturing plant in St. Thomas, Ontario, just across the border from Michigan. So next slide, please.
And as Patrick said, we're experiencing a slight delay with the timing of the slides loading because, you know, the internet has to transmit across international borders. That's how it works, right?
Yes.
Bear
Okay,
with
the
us.
first slides, the next slide is on my screen, so we're good.
Good.
Okay, so the topic for today's presentation is affordable housing. Next slide, please, Sandra. So before I get into it, I just wanted to take a few minutes to talk about what's happening in this mass timber revolution. We're in the midst of a revolution that began in Europe about 30 years ago and has landed on the shores of British Columbia about 10 or 12 years ago. The revolution is characterized by buildings that are being prefabricated off-site and shipped to site where they are being assembled rather than constructed in the traditional sense. The building that you see here is the Brock Commons student residence at the University of British Columbia. I think it's reflective of the future of mass timber construction. The building is constructed on a concrete podium, on top of which sit the glulam columns that you see on the left-hand side. And then on top of the glulam columns sit these massive wooden panels that are called CLT, or cross-laminated timber panels. So it's really just a series of glulam columns and CLT panels. What's also very interesting about this building is the use of the prefabricated envelope panels that you see here. These are panels that are made in the factory. They come with the panel structure, the cladding, and the windows pre-installed. And as the structure of the building goes up a few floors, the panels immediately follow, and they're flown into place, and they're quickly fastened to the outside of the building. So this particular building that stands at 18 stories was rendered completely weathertight in only 9.5 weeks. Although there were mass timber buildings in Canada prior to this building, I believe that this building really kicked off the mass timber revolution in North America. And this building has been completed about, maybe 2 or 3 years ago. Next slide, please. So the wave of the use of these materials and the wave of this form of offsite manufacturing, as I say, landed on the shores of British Columbia quite some time ago and has worked its way all the way across the country. Ontario has taken up mass timber in a big way, and these photographs or renderings that you see here are just a small selection of the projects that are in various stages of design, development, or construction in the province of Ontario. There's probably about 25 large buildings in various stages of design. Interestingly, the education space has been driving a lot of that, and almost every major college or university in the province of Ontario is building a mass timber building. Next slide, please. So what are the things that are driving this industry? I think it really falls into three categories. Firstly, from the owner developer's perspective, this represents an opportunity for owners to make a higher return on investment. You know, the whole prospect of being able to manufacture buildings in a factory and assemble them rather than constructing them on site. We're able to build it competitively or actually in often many cases lower than concrete or steel. One of the nice things about these buildings is people are willing to pay a premium to be in these absolutely beautiful buildings on the inside. So that means lower cost to construct, a higher selling price, and a higher return on investment for owners and developers. So there's a large contingency of owners and developers that are driving this industry. From the environmental perspective, world population is growing from 7.8 billion people today to 9.8 billion people over the next 30 years. The concrete and the steel industries are responsible for somewhere between 12 to 14% of the carbon dioxide emissions in the atmosphere today. So we know that as population grows, we cannot continue to build the way we've been building for the last 100 years, and the world is desperate for climate change solutions. When we're building with wood, what we're doing is we're leveraging our forest's natural ability to absorb carbon dioxide and to store the remaining carbon in ever increasing amounts of wood. When you manage your forest correctly, as we do here in Northern Ontario, in North America rather, what we have done effectively is, unlike the concrete and the steel industries that are spewing all this carbon dioxide into the atmosphere, we have found a systematic way of removing it from the atmosphere and storing it in the form of these beautiful buildings. And the last thing is what I refer to as the human factor. And fundamentally, in my opinion, I think it's really this human factor that's driving this industry. As populations grow, we know that 80% of that growth is going to be in urban centers. Cities will be densifying, buildings will be getting taller, and as humans, we're becoming farther removed from our natural environment. Building with wood, therefore, allows us to bring natural elements into our working, living and education environments in urban centers. And I think it's fundamentally that human desire to connect with nature that's driving this demand in our industry. Next slide, please. So just a little bit more about element 5 here. So the company was founded in 2015. We had our first CLT manufacturing plant by mid-2017 in a small town in Quebec, just outside of Ottawa. We always had our sights set on the much larger opportunity, and that was to build a facility in Southern Ontario. That also gave us ready access to the whole central part of the United States and the whole eastern seaboard, where we're seeing tremendous opportunity. The photograph that you see on the left is of our brand new facility in St. Thomas, Ontario. It's quite a large facility. It's 137,000 square feet. Even though the Europeans are 30 years ahead of us in this industry, this is considered the most fully automated mass timber manufacturing plant in North America. We have the capacity to produce 45,000 cubic meters of CLT and 5,000 cubic meters of glulam. To put that in perspective, referring back to the Brock Commons building, that 18-story building that I showed you at the beginning of the presentation, we have the capacity to produce about 20 of those buildings per year. Or as we get into affordable housing here, and I show you this building, we have the capacity to produce about 80 of the affordable housing buildings that I'm about to show you. The last thing is we are vertically integrated. So the major shareholders in Element 5 are also the major shareholders in sawmills in Northern Ontario. So because of that strategic relationship, we're able to control our supply chain right from forest floor through to finished product. And all of the wood that we source comes from FSC certified forests. One of the other things that I'm particularly excited about in Michigan is the opportunity to use Michigan wood in Michigan projects. And you'll see at the tail end of the presentation geographically how close we are actually, and the opportunity that presents to be able to use Michigan wood in Michigan project and other projects in the United States. Next slide, please. So about a year ago, I got together with a friend of mine, Matt Boland, and he's going to be joining us in the Q&A session at the end. And Matt is an architect with Edge Architects. We had worked a couple projects together, and we said, well, you know, Ontario has this massive affordable housing crisis. Because we can manufacture buildings cheaper, we can make them faster, we can create these wonderful, healthy environments for people. Maybe we have at least part of the solution to the affordable housing crisis. So what we did is we got together and we started designing a MassTimber affordable housing solution. And within a couple months, we had our first opportunity to bid a project. It was for the YWCA in a town called Kitchener, in Southern Ontario. And so what happened there is it came out to tender as a design build project. And together with Matt, we created our own consortium. And in that consortium, we had an architect, a general contractor, a code consultant, an envelope consultant, an acoustic consultant, and mechanical consultants. And we formed our own team, and we went up against about 4 or 5 other teams. We went up against the guys that are doing like the about 4 or 5 of the other major affordable housing manufacturers in the province here. And so we went up against the guys that were doing light wood frame construction, precast concrete, the guys that are doing volumetric. So there's a group of people here that would buy old shipping containers and convert those into housing units. And then there's also the volumetric guys that are creating these volumetric boxes in a plant. They'd ship them to site in box form, and then they'd assemble them, you know, side by side and on top of each other to create these structures. We honestly didn't know whether we would be competitive or not. There's always this stereotypical view in the marketplace that mass timber is more expensive than other forms of construction. We particularly chose affordable housing, one, because we felt we could make a positive contribution to our communities, but we also wanted to disprove the myth that mass timber was more expensive than other forms of construction. So lo and behold, we were very pleased to find out that our solution was the lowest price solution of all of the other contenders that we went up against, and we won the project. And so this is the design we came up with. Part of it, of course, was stipulated by the owners. They wanted a certain number of units. They wanted it to be a certain size. They wanted it to be a certain number of floors. And this is the design that we had come up with. Next slide, please. So to give you a sense of the mass timber components in the structure, so we use CLT for the floor slabs. We use CLT for the roof slabs. We use CLT for the demising walls between all of the units, for the elevator shafts, and for the stairwells. And in addition to that, we were using our clip system, our prefabricated exterior wall panels, as cladding materials for the outside of the building so that we can quickly enclose the whole structure. This particular building was built on a concrete podium, although it doesn't need to be. We could easily build, you know, with underground parking, not a problem. And so the building is entirely mass timber from slab up. Next slide, please. This slide will give you an indication as to what the interior of these units will look like. Because of the biophilic advantages associated with mass timber exposing occupants to natural elements, we wanted to expose as much wood as we were able to in this design. So the original idea was that we were going to expose the underside of the CLT panels, which you can see here, and we can show at least the inside of the exterior walls on the outside of the building. The image on the right is what the interior of the lobby of this building will look like. And again, we're trying to expose it. Many people who look at this say that doesn't look like affordable housing to me, because there's a perception in the marketplace that affordable housing is a cheap form of construction and you use inferior grades of materials on the inside in order to be cost competitive. But in this case, we're creating these absolutely beautiful structures, and we figured out how to do it cost effectively. Next slide, please. So there are some features and benefits in this form of construction. The first one is affordability. We've proven with the YW project that we are affordable in the marketplace, so we can in fact build affordable housing using mass timber. The YW was not an anomaly. We also tested that by winning other projects. We've since won 5 other affordable housing projects in the province of Ontario. We've just delivered our second affordable housing project in December. So we've proven repeatedly that we can be cost competitive in the affordable housing space. The building is really rapid to assemble. So we bid the YW project in the end of February. I don't think we received the contract on that building till around the first week of May. Bear in mind that when we won the contract, we didn't even have drawings because it was a design build tender. So from the beginning of May, we were able to get building permits within 6 weeks, and we had our first materials arrive around the 3rd week of September. This particular project, there was some government funding associated with this, and the stipulation was that we had this project up within 12 months and occupied. So having won the building in around the beginning of May, the building is slated for occupancy by the middle of March. So very rapid construction. Thirdly, durable and safe. Toronto has this rich history of construction using mass timber. There's about 150 of these beautiful, what we call brick and beam buildings. You shouldn't call them mass timber, you should call them heavy timber buildings here. And some of these are buildings that were built between the 1850s and the 1920s. So there are buildings in Toronto, heavy timber buildings, much like the ones we have here, that have been around for 150 to 170 years. So we expect the life expectancy on this affordable housing project to be well over 100 years. And of course, because they're durable, they're also secure. Last advantage is they're healthy. Again, the biophilic advantages of this, we're creating these wonderful, healthy, nurturing environments for people. Next slide, please. A few other features and benefits. The construction is sustainable. We're using natural, renewable, sustainably harvested materials to construct the superstructure of this building. So we know we're using sustainable, environmentally friendly materials. Everything is customizable. There is a structural design in this that reduces overall costs. It's important when you're designing with mass timber that you design it as a mass timber building to begin with, because there's optimum ratios between grid patterns and the thicknesses of the CLT that makes up the floor structures. Ideally, you want to design the building to reduce the amount of wood that's involved in design, so that there are some structural design parameters that you want to make sure that you're designing within, but it still provides you a significant degree of customization. So we can change the size of the footprint, we can change the number of floors, we can change the room layout. This affordable housing building was designed all with small units. I think they were all single bedroom units, just under 400 square feet. But the structural design allows us to do studios, 1 bedrooms, 2 bedrooms, and beyond. So a great degree of flexibility. They're energy efficient. Because of the tightness with which the CLT panels come together, we make a CLT panel that's about 11 feet wide by up to 53 feet in length, and we have a tolerance of only 1/8 of an inch over 53 feet. So the panels are exceptionally precise, and they fit together incredibly tightly. And so because of that, and also because of the thermal insulation properties of the wood, these buildings are naturally high performing. These buildings are high performing buildings. And lastly, they're construction safe, and that is because most of the construction work or manufacturing work is done in a controlled factory environment and requires fewer construction workers on site, and certainly a shorter period of time in which to construct the building. Next slide, please. This is a photograph of about the last 25% of our plant, and already past the equipment that manufactures this. This is kind of like our fabrication end of the plant. And the panels that you see there on the right, these are the panels that were used in the YW project. They've just come off the line. And so what we do is we pick them up with the overhead gantry that you see there, and we move them to the left where you see a little bit of our CNC equipment. And there we trim off the panels, we pre-cut all of the window and door openings. Usually there is a BIM model for this where we're integrating the mechanical systems early into the design of this. And if there's any penetrations that are necessary to install ductwork and those kinds of things in the CLT panels, that ideally we want to draw those in the BIM model and pre-cut those in the factory to facilitate the implementation or the installation of the mechanical system. So every panel is numbered and has a unique location where it fits within the structure. And so beyond that, they all get covered and they go onto a flatbed truck and they are shipped to site where they are assembled, much like IKEA furniture. Next slide, please. So this is the YW project in construction. And so this is about a 25,000 square foot building. It's a 41 unit design. It uses the structure that I've indicated previously. You'll notice the panels on the left-hand side, they're horizontal. Those are structural panels on the shorter ends of the building, because those panels actually support the CLT slabs at each floor level. But the panels that you see on the longer walls of the building, those are non-structural. Those are single panels that are 4 stories tall. So the panels in this case will be either 8 or 10 feet wide. They're vertical panels. The vertical panels are the full length of the building. And when we were erecting this building, I believe those non-structural panels went on the building in about 10 days. That whole structure that you see there was assembled in only 20 working days. So if that gives you any indication as how quickly the superstructure goes up, you can see that there's significant time savings there. Next slide, please. So for the majority of projects that we do our own carbon impact assessment. This particular building has a total carbon benefit of about 730 metric tons of carbon dioxide. That's made up of 527 metric tons of carbon dioxide that's actually stored in the wood. So this is the amount of carbon dioxide that our forests have absorbed from the environment and stored it in the form of the wood that's included in this building. And then there's about another 204 metric tons of avoided greenhouse gas emissions. Had we built this building out of concrete and steel, that would be another 240 metric tons of carbon dioxide that would have been spewed into the atmosphere. So the total benefit is about 730 metric tons of carbon dioxide. And that is the equivalent to removing about 154 cars off the road per year. Next slide. So part of the solution that we offer is not just the components of the structure. Here in Ontario, there still aren't a lot of architects, engineers, and consultants that know a lot about mass timber construction. So what we did is we assembled this team of the people in our geography who know the most about this form of construction as part of our bidding process. So not only are we making the products available, but we're making those services available to anybody who wants to build affordable housing. So in the absence of a owner or architect's preference for their own consultants to involve in a project, we have a whole host of people that we can introduce to your project, so we can offer both an integrated suite of not only products, but services to help handhold those projects come to fruition. Next slide, please. A little bit more about Element 5. So we had our first manufacturing plant in mid-2017, and during the last 2.5 years before our St. Thomas plant went online, we had done about 40 projects. This is just a small selection of the projects that we had done. So during that time, we had won some projects, delivered some projects, built a pretty good reputation for ourselves, and built a strong service component of our business here. And so, again, that's just a selection of some of our favorite ones. Next slide, please. So this, admittedly, as we started, we were looking at any project imaginable. And so we took a bit of a shotgun approach to anything and everything. And most of those projects were sort of small to medium-sized projects, but we were graduated into the major leagues with the award of this project, which is called the Toronto Regional Conservation Authority project. This is an 80,000 square foot combination 3- and 4-story office building. It is in the city of Toronto. And this photograph was taken about a month ago. And we've just finished construction of that. So the MassTimber structure is now complete. Our responsibility for this project is we took a design assistance role to help re-engineer this building, redesign all of the steel connections, optimize it to reduce the overall cost. And we also took the contract for the installation of it. Next slide, please. Not getting any better.
It's coming.
The largest project that we've won to date is called, excuse me, Trinity College. It's for the University of Toronto here. It's 167 unit student residence. It is designed and engineered much like our affordable housing solution. So it's a post and beam structural solution that uses our prefabricated exterior wall panels for the outside of it. And we've been contracted to provide design assistance as a consortium member of the overall project. And assuming the project goes ahead as anticipated, we will supply our materials to the project by around August of this year. Next slide, please. I think the next slide is really just oh, sorry, there's a little more. So we're a full service organization. We provide products and services. So the first question is almost, how much is a MassTimber version of this building I want to build going to be? And so we typically will look at early stage designs, we'll do some pre-engineering work, and we'll put together a comprehensive cost analysis that includes the supply, the connections, the services, the shipping to site, the how much it's going to cost to assemble, the number of man days, the schedule. And with that information, you can make an informed decision whether it makes sense, whether to go ahead with a MassTimber project or stick to traditional construction. And we can help you make that determination at the early stage of the project. And we usually do that free of charge to help handhold these projects at the beginning. We provide design consulting, working with third-party architects. We're not architects ourselves, but we work with third parties, much like we did with Edge Architects. We typically provide all of the MassTimber engineering component of it. There's usually an engineer of record on site, which is independent of us, but we typically take the engineering for the MassTimber structure. Of course, we do the fabrication, and in most cases, we take the assembly of the structure. That's a little more challenging for us in the US marketplace because of immigration rules, but we have connections with installers for other projects we're working with in the States that we can figure out, if necessary, how to take responsibility for the assembly of your structures there. Next slide. Main components we produce are CLT, as I've mentioned. We make the widest panel in North America, up to 11 feet wide by 53 feet in length and about 15 inches in thickness. Our panels are slightly different than other CLT panels in North America. We make an edge glued panel. That means, like most manufacturers in North America, only apply glue to the broader surfaces of the 2x6s that are used to make up the CLT. They don't put glue on the shorter edge of the lamella where the two panels come together in plane. So what happens is a non-edge glued panel, as it acclimatizes to the environment, will tend to separate on the visible surface of the panel, which makes it a little bit unsightly. Ours reduces the likelihood of separation between the lamella by about 90%. So it's a much nicer, aesthetically pleasing panel than what's typically available here. Glulam we make, those are all the columns and the beams. And lastly, we make our CLT insulated panels. These are the prefabricated panels we make in our plant, and they come with an interior CLT layer, vapor permeable layer. We can pre-install the insulation and the strapping. This is an evolving product, we've done about 4 or 5 projects to date with it. We have yet to pre-install the cladding in the plant. So most of the cladding is site applied, but as the product matures, as we continue to do research and development and get certification, we will be able to apply the cladding in the plant. So that's stay tuned for that. That's happening fairly quickly. Again, a high performance panel. Next slide. I just wanted to point out, and I didn't realize this until I was asked to do this presentation on exactly how close we are. Quite surprising. I live in Northern Ontario, and I'm a 3.5-hour drive away from our St. Thomas plant. Fortunately, I'm able to work remotely. So it actually takes me more time to drive to my home from St. Thomas than it would to drive to Michigan State University. It's only 3 hours and 11 minutes to Michigan State University. You know, we consider Toronto and, you know, Southern Ontario to be our primary geographic sector. You know, we see those opportunities go well into the United States and the central United States and the whole eastern seaboard. But actually, Detroit is in fact closer to our St. Thomas plant than Toronto is. And I did some research on Detroit, and I can see that there's a tremendous need for affordable housing in the city of Detroit. And so it's nice to know that we're actually that close. And so in terms of shipping cost and lowering the overall cost to be able to get our affordable housing solutions to Detroit, I think we can be quite competitive against other forms of construction. That concludes my presentation. So once again, thank you very much, Sandra, for the opportunity to present, and all of those who've taken the time to join us. And I believe we're going to proceed to a Q&A session now.
We certainly are. And Patrick, thank you so much for that presentation. It was really helpful. And I've heard you talk about this affordable housing MassTimber product several times now, and I always learn something new each time. And I think the evidence that there's significant interest in what you're talking about comes in the form of the many, many questions we have received during your presentation. So I think we're going to have a great discussion. So with that said, let me advance the slide. I'm going to try to advance the slide. And welcome to join us, Nicholas Zeeb, Senior Design and Cost Consultant at Element 5, so works with Patrick on the Element 5 team, and Matt Bolin, Principal at Edge Architects. And Patrick mentioned Matt and Edge Architects earlier in this conversation as kind of like the first kind of partner in crime on this affordable housing development. And I think Matt and Nicholas, I need to make you, for some reason it's being weird today, I think I need to make you co-hosts in order for you to be able to turn on your cameras, which I'm doing right now. And once I do that, see if you can turn on your cameras so we can see you. Nicholas, it's not even letting me do that. Oh, here's the problem. Can you guys do that, or does it not work for you? You can unmute for me. I see Matt. Hi, Matt.
Hello.
Nicholas, are you able to turn on your camera?
Unfortunately, it still says that I cannot. Sorry about that.
No, you may be invisible, and if that's true, I'm very sorry about that, but I don't want to take too much time trying to do technical troubleshooting. So I apologize for that. Hopefully we can see you next time. So you guys, thanks for joining us, Nicholas and Matt. It's nice to see you. It's nice to meet you. And I think we are going to just launch into this large list of smart questions that people have been asking during Patrick's presentation. And I think I'm going to stop sharing my screen now so we can just see everyone's face a little bit better. And maybe when you guys are talking, I can try to troubleshoot Nicholas's camera. So the first question is, and I wrote them down on paper in spite of the fact that I have two computers in front of me right now. What type of coding is on the floor to reduce noise transfer in these affordable housing buildings?
I'm going to turn that over to Matt.
Yeah, I guess. Yeah, you've done all the heavy lifting thus far. So yeah, sure. I'll take that one. I will say over the past, well, year for sure, my acoustic knowledge and expertise has basically been on a very sharp incline in terms of understanding that. For us in Ontario and Canada wide, specifically with our building codes, acoustic performance is actually specified for residential environments. I'm not sure if that's similar in Michigan. So it's a big aspect and something that we did definitely need to address. So there's a number of different ways and different products that can be used. We have chosen on this first project, and as Patrick's saying, some of the subsequent both affordable housing, supportive housing, and market rate based apartment style buildings utilizing MassTimber. We have actually gone with a concrete topping, and that concrete topping is basically put on top of a decoupling rubber underlayment. So that's the common way to do it. One of the nice things about that, even from the construction industry standpoint, is one of the major other systems that Patrick brought up was precast concrete, particularly precast planks with various different types of vertical support, and always in a precast plank hollow core plank style project, you'd always have that topping as part of the process. So it's very sort of understood. Even though we did take and have worked with Nicholas and other people at Element 5's team to try and have all of our designs pull out every last bit of efficiency, there is also an importance for us to understand, and we've been working our firm and myself particularly for well over a decade now in the multi-residential space, and understanding the conventional industry and the conventional building systems is a really important thing, so that you can create apples to apples comparisons on pricing, and then also in terms of trade knowledge for how they're actually fitting out these spaces. Keeping as much consistency as you can there has been our strategy. So that's what we've chosen to do here. I will say though, and Patrick referred to some projects we worked on before this YW project that we had all the success with on the rapid housing side. We did work prior to that actually on some innovative research projects where we looked at a number of different, what I would call dry applications. So where it doesn't require a sort of a wet concrete application, that things that just can be layered on. And there's a lot of great products, a number of really good, both consultants and acoustic product suppliers who can work with, any project and give lots of great feedback there. So.
Matt, thanks. That was a great response. And I appreciate that you talked about some of the other options you considered and why you went with the one that you did. Did Nicholas or Patrick need to add to that one? All right, then we're going to move on to the next question, which is, there were 41 units in the building, the YWCA affordable housing building that you're working on. Somebody asked, what is the average cost per completed unit? I don't think I heard that number shared. If you can share that with us.
You want to take that, Matt, or do you want to leave it to me?
Sure. Well, I mean, it's probably the biggest qualifier there is the conversion rate, right? So we'd be speaking in Canadian dollars versus US dollars, which there is a difference. And one of the challenges too. So we actually, as Patrick mentioned, there's a number of projects that have happened since YW, including we've just been greenlit for building 2 on the same site for YW, which is a really interesting and exciting when you can start to repeat and see a lot of efficiencies, particularly when it comes to your site planning and servicing. But what we've seen over the last year, as I'm sure is probably consistent North America wide, is some pretty intense volatility in supply chains in the construction industry, as well as just escalation, in part because of the supply chain issues, because of labor shortages, general inflation, starting to creep up. So we're seeing some truly volatile impacts on our pricing. So I'll preface it by saying that, and I'll also preface it by saying we're going to be speaking in Canadian dollars for the purposes of this conversation. I think the question in the Q&A maybe had referenced a per unit. which is a bit more challenging, and I don't have the breakdown of that. We are typically talking about things in terms of per square foot. Per unit cost on this particular project, because the units are quite small, it's intended for transitional housing for women battling homelessness. So the units were very, very small, like Patrick saying, just under 400 square feet. That said, the big challenge for us was to create a separate bedroom within that. So they're not the long, the typical long, deep studios with sort of a Murphy bed style. These are actual more square layout units with an actual bedroom that can have a door closed. It was part of the client's requirement. And just frankly, I think a nicer layout from residential living. But that said, the units are quite small. So we are using, particularly when it comes to, to talking and just analyzing that apples to apples comparison on the structural system, the overall build costs for everything, including site works, that we've been working within is, I would say it was just under 300 when we started the project. It's now probably skewing closer to 350 as we're working our way up. And I think the important thing to note there is that's really multi-res going rates outside of the MassTimber. We did also, as part of this project, one of the, I think, Patrick and I spoke when we originally started down this path for this project was, what is the number, the quote that Element 5 is going to come and deliver to, to the team specifically for the MassTimber package. How is that going to compare with conventional systems like precast concrete, stick frame wood, and others? And predominantly the precast concrete option, which is a more robust way to build. Stick frame is a little bit just sort of a different animal. And when you're looking in the supportive and particularly supportive housing, you need, oftentimes there's a willingness to invest in something a little more robust. And so we knew that we had to hit that mark, and we did essentially. And that's in the and Patrick or Nicholas, you could probably, if we're talking at high levels, it was that $60 to $70 a square foot for the call it the superstructure that we were able to hit, comparatively with other systems. The great thing though, and we had a builder, our design builder on the file had a lot of experience with precast, which actually helped us because, getting them on board with this was a really win for, and having them become champions like us for the system was really great. But the other piece to that is that it wasn't just the price, it was also just the delivery. So for example, if you go to all the precast suppliers that we could draw from, none of them could put us in their queue for 12 months. And that basically would have used up our entire window for the project start to finish. When it comes to, that's one of the biggest things we've seen is that our ability, and when I say our, I mean the construction industry, designers, people working through the approvals, as well as the actual construction and construction documents, our ability to work through these projects quickly on the design and construct and approvals and construction is so paramount. That's the biggest way we're going to move the needle on pricing, and it has the byproduct of delivering housing to the much needed population that much sooner. So sorry, long-winded answer, but
the only thing I can add to that is, so you said around 350, but that includes all the soft costs as well, right?
Yes. Yeah, those are all
so that's
in
all
numbers.
Those are all the architectural costs as well. And you made reference to Element 5 around $70 a square foot for the Element 5 package, but that also includes the assembly of the structure as well, just not the materials and the connections, and it includes
Correct.
the engineering and the whole package from us, including the install.
Yeah, and
so
that also included the clips, the cladding system as well. So
correct, yeah. And so it is relative, we have Canadian labor rates, which I understand exceed those in Michigan area. And also I think the key thing is to look at is all the same competitors that we have in the Canadian market. I'm assuming that you would have in the US market, the lightwood frame, precast concrete, volumetric guys. I think the point is we went up against all those competitors here in Ontario. And if you go up against all those same competitors in Michigan, for example, I think you'll find that MassTimber is still, a cost competitive alternative to those other competitors.
Yeah, thanks for breaking that all down. I'm sure that was very helpful for the folks who wanted to know more about kind of how the numbers add up. YWCA building is, and what is the fire rating? Can someone address that, please?
Yeah, I can probably take that one too. And actually, this is probably going to end up working out well. I'll just preface by saying, Patrick, I got to jump off at one, but if we need to extend further, I'm fielding all the questions now, and we'll need Nicholas to probably weigh in with his expertise here, particularly structurally. Anyways, so I think that'll be fine. It's a residential, a multi-unit residential classification, not institutional. It is transitional housing, but again, we still fit into the typical. I mean, for us, it's a C occupancy, which is residential. Our fire ratings that came as part of that were 1 hour, and we're able to achieve that quite easily, with the exception our demising wall. It's sort of a push and pull. You can achieve it through the thickness of the mass timber, both for walls and floors. Oftentimes, the rating you require versus the structural thickness you require usually work out. In the case of our demising walls on these projects, we were actually able to make the walls thinner, which reduced our volume of wood and made it more efficient. Only downside to that was that reduction in thickness of that product didn't allow us to hit the 1 hour rating for those demising walls. That said, strategically, then we also realized that our plumbing and our kitchens were always on those walls. And we also had some acoustic items to deal with flankage from one unit to other. So we chose on those walls to actually put furring and drywall, which ended up dealing with both the fire rating, the acoustics, and just covering up all those services and penetrations.
Thank you. That's helpful to understand. We have so many questions that I'm now having trouble deciding which ones to throw out there. Patrick, there's one question in the Q&A that you just might want to take a look at from Bernard. I think that's a very specific question for you, and you might want to answer that separately. There's a question about are pathways embedded in the cross-laminated timber for power, data cabling, ceiling mounted devices and fixtures, et cetera. How's that handled in your model?
I'm just going to sit back and let you sweat it, Matt.
Matt, you're working harder than
until you have to leave.
That's good. It's like rapid fire. It's great. So it can be done, and Nicholas should probably weigh in on this as well. One of the things with our speed, coordination, we do our full working drawing sets. We use BIM, Revit with all of our consultants, and Element 5 actively works with us, but then they also take that model once we get it to our point of initial for construction model, and they take it even further with details and coordination of every last fastener and clip and screw. That at that stage is where that sort of coordination could definitely happen. I mean, it definitely does happen for any penetrations for mechanical and plumbing and a lot of those things. To go to the extent of routering in lines for conduit and all those sorts of things, again, I think it's possible for us at the stage we're at now, and how we've strategically gone about it. We haven't invested the time or effort in doing that, and I assume there would be cost to it, but also with just the nature of how complex and detailed the modeling is for fabrication purposes from Element 5, I assume it's possible, but I'll kick that one to Nicholas.
Yeah, I can jump in here with the rest of that question. So Matt, you covered it very well. Our state-of-the-art CNC machine at the factory can cut really anything that you need to into 5 sides of a 6-sided panel. We can do drilling, coring, the chainsawing. Really anything is possible. It just really does come down to the coordination aspect of it. Every raceway that gets added requires another approval from the electrical subcontractor, mechanical subcontractor that needs to verify that it's in the right place. And then the other side of it is that additional time in the CNC machine both adds cost from just a machining perspective, but then also slows down your potential production. If we can make the exact same panel over and over and over again and cut it square, then it's a very efficient process. And that's when you're really getting the efficiency of prefabricating on site. If every panel now has a very unique channel in it, it's not that it's not possible, it just adds more time, and it needs to be a consideration on what to balance in the project.
Thank you, that's very helpful. Since we're getting close to time and we have a policy that we end on time in these webinars, I'm going to ask one more question that's specifically related to affordable housing. Some of the other questions are more about mass timber manufacture, and maybe we can capture those questions and then answer them in a follow-up message to the participants in this webinar. So I'll collect those and then share them with you guys, and we can coordinate getting those answers. But the last question I'll ask here is, these examples that you're working on at Element 5 are mid/high-rise, mostly mid-rise, multifamily units. And there's questions about, are there examples of using mass timber for smaller scale construction like triplexes, duplexes, accessory dwelling units? And I don't know if you guys have done any projects like that. I don't think you have, but if you haven't, why not? And do you have any sense of how affordability stacks up at those smaller scales with mass timber?
So I can take a stab at that one. And I like accessory dwelling units is something that's dear to Matt's heart as well. So maybe he can take a moment to comment about it as well. One of the things that is fantastic about mass timber is we're seeing it used in almost every building typology across almost every industry segment. It's probably a lot easier to talk about where mass timber doesn't make a lot of sense. You know, really tall wood buildings. You know, we're seeing buildings in, I think there's a building now in Milwaukee. It's what, 25 stories in mass timber. You know, we have 10 and 12 story buildings in Canada. Certainly going beyond that, mass timber is a challenge. So no question about that at this point, particularly for code and legislation that allows us to go to those heights. We're probably more able to accomplish it than code will allow us to at the moment. Challenging as well in the single family space. You know, it's really hard to compete against light wood frame. Light wood frame materials are available everywhere. You know, when you're talking about mass timber, these are big, heavy panels, and they're typically shipped longer distances. So we're challenged to be competitive in the single family home space. Where it makes sense is if you're going to have a subdivision where you're having 3 or 4 designs and you're repeating the same thing over and over again, then we can prove to be cost effective with repeatable sorts of solutions. But we're seeing everything from single family homes up to these, you know, 650,000 square foot offices or 25 story buildings and everything in between. One other location where we're seeing it quite challenging against steel is industrial buildings, much like our own building, like our factory, 137,000 square feet. It made sense to do that out of metal. Plus, we didn't have a plant at that time, which means we would have had to use a competitor's product, which they would have held against us for our lifetime. Yeah, well, they built their factory out of our product. But anyway, so we decided that it made sense to use metal there. So there are some cases where it makes more sense, but the beauty is we're seeing mass timber in almost every industry segment, every building typology.
That's great. Thank you so much for sharing that insight. I want to thank everybody for their participation today in this Mass Timber webinar. I think this conversation has been really insightful and enlightening as it relates to really the very real potential of using mass timber in affordable housing in North America. And, you know, Element 5 is helping to pave the way for that along with some other stakeholders in the space. And we are going to follow what's happening there and help you get in touch with resources that can help you do affordable housing projects with mass timber in Michigan. I'm just trying to get back to this screen. So this is Patrick's contact information. If you do have questions for Patrick, he's left his information here for you to use it. And I think that is very generous. I also want to thank Nicholas Zeeb and Matt Bolin, who has already stepped away, for their participation today, and to all of the folks who have been here in the audience with us through the duration of this webinar for your attention and your wonderful questions that contributed to this fantastic discussion. We will be doing a mass timber webinar in February. Please stay tuned for information about that. If you have questions about mass timber at MSU, want to be directly informed about these webinars, et cetera, please use my contact information, which you can see here on your screen now. And finally, we will be, when we have, excuse me, finally, we have recorded this webinar, and we will be sharing that with everybody on this list, along with some follow-up resources that I mentioned during the call. So with that, Patrick Chouinard, thank you for your participation today and your presentation on behalf of Element 5. And thanks to everybody for participating. We'll see you next time.